2020 question 7, first of the long questions. A number in the form 1 plus 2 plus 3 plus n is a triangular number. It reminds me of snooker balls being racked, or pool balls being racked, or pin balls being racked. We can see here in this first sequence there's 1 here, there's 3 here, we add another 3, we get 6. If we add another 4, we're going to get 10. We add 5, we get 15. We add 6, we get 21. We add 7, we get 28. We add 8, we get 36. Then we're told the nth triangular number can be found directly using this formula: Tn is equal to n times n plus 1 over 2. Is this a triangular number? Well, if we let n by n plus 1 over 2 equals 1275, we can see very quickly it is a triangular number. So we're going to get n squared plus n. Rather than saying equals 242550, I'm going to take the 2550 back across. That looks like 50 51s. Just double check, it is 50 and 51. So n by m 50 and n and 51, and we need a plus n, so it needs to be plus 51 minus 50 to give plus n. So n is equal to 50 or minus 51, which n can't be, so we dismiss. So we say n is equal to 50, therefore 1275, 50th triangular number. I'm just going to use that symbol for number. Now the n plus 1th triangular number can be written out as Tn plus 1 is equal to Tn plus n plus 1, where n is an element of natural numbers. So write this expression as a single fraction in its simplest form. Okay, well, there's a couple of ways to do this. We have n times n plus 1 over 2 plus n plus 1 over 1. I'll just cross multiply here. So we're going to get n by n plus 1 plus 2 by n plus 1 over 2, which is going to be n squared plus n plus 2n plus 2 over 2. Come up here, n squared plus 3n plus 2 over 2, which factorizes to be n plus 2 by n plus 1 over 2, which I think is as simple as this gets. Then prove that the sum of any two consecutive triangular numbers, well, we have that the next one in the sequence is this n plus 2 by n plus 1 over 2. n plus 2 by n plus 1 over 2 is the n plus 1th, and Tn was this n by n plus 1 over 2, n by n plus 1 over 2. So the sum of these two things will always be a square number. So let's get this into something squared. So we have n by n plus 1 and n plus 2 by n plus 1. So we could simplify that way. Or we could just bring the numerators together. Let's have a look at multiplying them out first. N squared plus n over 2 plus n squared plus 3n plus 2 over 2 to give 2n squared plus 4n plus 2 over 2. Coming up here is going to be n squared plus 2n plus 1, which is n plus 1 to be squared, which is equal to k squared, therefore always true. So two consecutive triangular numbers sum to 12544. Find the smaller of these two numbers. Well, we've just gotten that n plus 1 squared is going to be equal to the sum of two consecutive numbers, 12544. If I get the square root of each half, or sorry, each side, football on the background, each half, n plus 1 is equal to 112 is the square root of that. So therefore n is equal to 112 minus 1, 111. So we're asked to find the smaller of these two numbers. So we know that the expression, let's go back up to the top here, n is equal to 111 this is Tn. So when n is equal to 1, 1, 1, Tn is equal to 1, 1, 1 by 1, 1, 2 over 2. So Tn is equal to, that gives me 6216 on a calculator.